noise, vibration, and harshness. Typically called NVH. There are job postings at the conference I am at, and there are a couple companies hiring NVH engineers, right? So this is a very good engineering job, and particularly in the automotive sector, we're trying to reduce the noise, vibration, and harshness of a car. Now, one of the challenges is when I add damping to a car, that requires added mass and added material, which increases the price. So we don't want to add damping that we can't add. I would love to have a picture of the Teslas, because theirs are really cool. They really do a good job on their NVH. But this is a picture of the safest car in the world. That's a joke. It's a Jaguar. Do you know why Jaguars are super safe? Anyone want to take a stab at that one?
Because they're really expensive?
Yeah, well, that too, but you can't get in an accident if your car doesn't run. So I love Jaguars. They are one of my favorite marques, so I can say that. I would totally buy one, but if your car sits in your driveway, it's pretty safe, right? It's funny to me. I don't know if it's funny to other people, but yeah, but the price does help, right? When the buyer of the car isn't purely driven on cost, you can get a much better car, right? And so it does take some value engineering to get that to work out. What these plates here these are basically rubber sheets. They're an epoxy on one side and a rubber sheet on the other side, and they are glued in to the frame, and they're typically done over large panels, right? So here you have a big panel, and if you've ever had a big piece of metal, it can be pretty easy to bend, right? And if you bend that metal, you might get a pop, kind of commonly called like a tin can sound. And these damping pads are here to help reduce the noise. Now, if you were building a car, maybe you want to add 100 pounds of damping because you just want a super quiet car, right? But that's going to reduce your mileage, cost more money, all of that. So they cut these big sheets on and they kind of put it strategically, right? You'll notice they put it here. That's where your feet are, right? You probably don't want to feel vibrations coming up through your feet. It's good to put it where people's seats are, right? And then you have this expanding foam that's put in between joints. If you've ever lived in an old house and you walk and it goes creak, 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 that's nails pulling in and out. But it's the same thing for cars. The panels will start to rub against each other with age, and then this material will help absorb that noise. This is also why you think wow, this car is old and it makes a lot of noise. One of the reasons is because this material starts to degrade, right? It doesn't last forever. They are a consumable item, and they will degrade. The same thing with the epoxy that holds these sheets on, right? They are a consumable item and they will slowly degrade. And so your job as an engineer is to make sure you pick the epoxy that will last 5, 10, 15 years, however long it is that you have a lifestyle, the lifespan of your car. And they're typically not really designed to last over 10 years, right? Cars aren't designed to last 100 years because it's just very expensive to do.